Welcome to Nameless Debate Radio, where radioactivity is contagious. You can join us in broadening our minds on the Nameless Debates Discord via the link below and even feature here yourself, if you've got what it takes.
How about them memes, though?
What memes?
The idiosyncratic behaviors that we all exhibit.
Yeah. So, Terence, let's go back to the is water wet argument.
Oh, I love that
Oh,
one.
I'm just kidding.
Dude, I love that one.
You do.
I don't even know what the answer to that is, dude.
It's not wet.
Yeah, but is that the case?
Because
How do you know?
wetness is a quality of a system that contains water and something else. So there
Is
can
that
be
the case? What's the condition for wetness?
Yeah.
The condition of wetness is there has to be water present and something else present.
So is something wet if there is just one molecule of water?
It's wetness can be like dripping, like it's
No, but
like
I'm not
it's
so
like
sure. Here's the contention in short form. I'm not actually sure if one molecule of water on something makes it wet. I don't know if that's true. It doesn't seem true.
99% water, 1%
perspective.
something else makes it wet.
No, but I'm saying, like, if there's only one molecule of water, I would think that wetness is a property that emerges from the aggregation of the molecules.
Yeah, okay, so it has to be liquid also. One molecule of water is
For sure.
So,
I mean, isn't it? It's liquid. It's in the liquid state, as in chemistry.
Yeah, but it's like, is ice wet?
No,
is
not really.
ice wet?
No, but
ice is
one molecule of water is a liquid chemically.
Yes.
No, I don't think so.
It is, dude. I'm telling you,
it
absolutely.
It is a liquid, but water is a wetness is an emergent property. You can't have wetness.
I agree, but what does wetness emerge from? Because I would say, in my opinion,
Liquids.
it seems. No, but it seems that wetness is an emergent property of the aggregation of the molecules.
It is.
Okay, so then you need more than one water molecule to make something wet. That's logical.
Yep. Oh no,
okay,
a molecule isn't a liquid because a liquid is a sort of fluid.
No, a liquid is a phase, dude. A liquid, gas, and solid. They're phases in chemistry.
Yeah.
If it's not ice, and it's not water vapor, and it has the chemical structure H2O, it is a liquid.
But the definition of a liquid is that it's a type of fluid which continually deforms under shear stress, and you can't deform a molecule.
Where are you getting that definition from?
Engineering textbook. No, this is Wikipedia, but I know.
Okay, so
I know that's the case. That is true.
A substance that flows freely but is of constant volume. So, one molecule of water fits that criteria.
Oh, but that's not really true either.
That's the Google definition.
Nothing is truly of constant volume. Everything is compressible to some degree.
Of course, no, but I think they mean like absent other factors, the volume stays constant, because that's not true of gases.
No, if you apply pressure to a gas, it will.
No, but I'm saying, like, even if you don't apply pressure to a gas, the volume changes. Like, gases are constantly changing volume.
Yeah, if it's not confined.
No, even if it is confined, like the actual volume changes over time as the gas molecules group up in certain places. Like, not for long, but the volume changes subtly.
Okay, sure.
Yeah, and that's not the case for liquids.
No, but they still have to deform under shear stress.
So that's what flows freely means.
Yeah.
Yeah, but I'm saying one molecule of water does do that.
No, or
it does.
Yeah,
does.
Or it bounces around, but it doesn't. it doesn't deform under shear stress.
No, I think it does deform. It's just that you can't see it deforming. Like,
I'm not so
realistically,
sure about that.
what you're saying when
Yeah,
you're
I think
saying
that's the case.
deform, what
Yeah.
you're saying when you're saying that it deforms is you're saying that the aggregate of the water molecules will adapt to a changing environment. But I'm
Yes.
telling you that the adaptation you're describing is just as mechanically present in one molecule of water. It's just that the scale is such that you can't see it doing that. Like,
I'm not really
so
sure that's true.
if
Actually,
if I tip a container on its side and it's got like a rounded corner and there's just one molecule of water, that one molecule of water will follow the container around the rounded corner in just the same way as it would even if there were a bunch of water molecules.
no, it would fall
How?
out, but not in the same way.
No. I'm
because-
saying like it's a rounded container, so I'm not tipping it out. I'm just like holding it such that the water that's on one side travels to the other side around a rounded corner.
I think it has to do with forces acting between
Avogadro's
the water molecules.
What
Because-
has to do with that? The deformation?
Yeah, if you have multiple molecules.
No, of
they
course. But I'm saying that the mechanical action of the molecule is not different because it's just one.
But you could say the same for a solid, right? If you had one molecule of iron, for example, it would behave the same way.
Okay, wait.
As
It
the water
sounds
molecule.
like you're making a phenomenological distinction. Like, chemically speaking, having one molecule of water is still a liquid if it's in the liquid state, right? Like if it's in terms of like a categorization in chemistry.
But the states has nothing to do with one or
No, but the
individual
state has
molecules.
different chemical properties. It does have something to do with individual molecules, dude. It absolutely does. Okay, when an individual molecule of water changes state, it has different properties.
What happens to the molecule when it changes state?
So if it changes state to a solid, it becomes rigid.
What about if it changes state to a plasma?
But that has to do with, for example, in crystallinity, for example.
Pardon?
Yeah,
Pardon?
in water, for example.
That has to do with what? Sorry.
Crystallinity. Given a certain
Crystallization. Yes.
Yeah, given a certain temperature, which is 0
No, but
degrees.
I'm saying that the molecule has different properties in a different temperature.
Okay,
Like it has
could be true,
has
but
a
I'm not
actual.
sure.
It has a distinction in the properties. Gases have distinct properties to liquids, have distinct properties to solids, and if you have one molecule of liquid water, it is still a liquid. Like by definition, it has to be.
I'm very uncertain about that.
In chemistry, one molecule of H2O in chemistry can be a liquid. I'm telling you.
Okay. Because I read a scientific paper, I think it was yesterday, about because previously we thought that there's always a layer of water surrounding ice. There's always also a layer of liquid water surrounding the ice, and that's why ice is slippery. You know this, correct, Terence?
Yeah.
I wouldn't consider it a layer of water molecules because the water molecules are scattered around, and that's why it's slippery.
Yeah, but that was what the scientists found out for. I think it was a year ago.
That state isn't wet, but when ice starts melting, then it becomes wet.
Yeah, sure. But those
But the question
molecules are
is-
not in. Those molecules are not liquid. They're just free molecules. So
Is that true? For instance,
think-
ice. I'm pretty sure ice skates turn them to liquid with the pressure of the person.
Yeah, but
making
like
friction.
ice alone isn't wet because the layer of molecules.
No. Look, we get that, Terence. Although I'd be interested to know if ice is wet when it just has one water molecule on it.
Yeah, sure. if you skate on the ice, then you will induce.
I don't think so. It's not wet because it's not an aggregation of water.
I agree, Terence, but I'm trying to figure out if that's the correct answer. Because I'm not actually sure. Like,
well, you can have, for example, there are things.
Water on water is fucked up.
yeah, dude.
'Cause
It seems to me like one molecule of water is not wet, but 2 molecules of water is wet, or maybe 3 molecules of water is wet.
3
I
molecules
don't even
of
know.
water.
You know, where is the wetness coming about?
But wetness is a quality of the system, right?
Yes, yeah, I know, but I'm
So
asking
it's like if you
do
keep
you have
adding
wetness?
neurons.
No, I know,
if you
I
keep-
understand. Do you
Yeah.
have wetness if you just have 2 though?
Depends on the system.
No, it
Depends
doesn't.
on-
It really doesn't. The quality should
really
become
does.
immediate. No, it doesn't,
It
man.
really
If I
does.
have
If you have two molecules
if
of
I have
water
a
and
book,
one molecule of something else.
stop.
If you have two
No,
molecules,
that is what I'm saying though. That's implied. I'm saying I have a book. There are 2 molecules of water on it. Is it wet?
No.
yes.
I think it probably is, right? So then here's the question. If you have 1 molecule of water and then there's one other molecule of water, is the water wet?
Are they in 2 different states?
No, they're together. They're
Then
in
no.
the same state. The water's not wet. How?
Because
Okay, what if you
water-
have 3? What if you have 3?
dude, it's like
So what if
99%
but I'm saying
water
like
plus something else is
but
wet.
I'm saying the something else is another molecule of water.
Yeah, that's what I'm saying. That's what I'm telling you. 99%
but
of water plus
I
something else
understand
is
that.
wet.
I understand that.
But
But what
99%
happens?
of water plus water is just a liquid.
No, but that's what I'm asking. I'm asking if 1 molecule of water surrounded by 2 other molecules of water, is that wet? Is the 1 molecule, the
No,
initial
that's a
molecule?
liquid. That's called
No,
a liquid.
stop. I understand that's called a liquid. You're not answering my question properly. Let's call the first molecule A. It's a special molecule. I'm tracking it. It's A, alright? So A is the same as if I have a book. Let's call the book B, right? If I have 1 molecule of the book and 2 molecules of water, you said B is wet. I'm saying if I have 1 A and 2 molecules of water on A, is A wet?
You can
It
distinguish
seems like,
the molecules
like
of water.
syllogistically, it seems like it has to be.
No, because still
Logically, if you
one
define the water,
one molecule cannot have a state. States depend on how molecules arrange themselves with respect to
1
each
molecule
other.
can't have a state. That's completely incorrect.
Do you have any
It's like-
do you have any source or something? Because I'm
How a
I don't
molecule
buy
can
this.
have a
if there's
state.
one molecule,
Yeah.
you can't really
Of
tell if it's a
course.
solid
Because
or a
this-
No, but you could, just because you can't tell doesn't mean it doesn't have a state. Let me give you an example, okay? So there's a stable molecule and there's an unstable molecule. That is a state, and you don't need to
Yeah.
have multiple molecules to know that.
But that doesn't have anything to do with solid.
It does.
liquid.
It totally
Isn't that
does.
the
You can just have
range?
one
No.
molecule. It's a state. You said 1 molecule cannot have a state. That's an absolute statement that you made about whether or not 1 molecule can have a
Okay.
state.
Yeah, okay, sure, it can be unstable or stable or
Yes, so that's a
super
state.
saturated or whatever. But
So then, are you saying that we
in
can't
terms-
tell
in
what state it
terms
has?
in terms of solid, liquid, or
No, but
gas
is the
states.
question is,
and
are you
plasma.
saying that we can't tell what state it is, or that it actually doesn't have a state?
No, it doesn't have.
Says who?
Doesn't it depend on the arrangement? And the
yeah,
arrangement gives it the property.
Yeah.
No, but the thing
state-
is that the arrangement is not a consequence of like the individual things coming together. It's a consequence of the property of all of the individual elements. If you
Yeah,
have 1
yeah, but
molecule
the
of water,
arrangement-
no, but wait.
The
If you have
arrangement
1
gives it
molecule
the
of water, I don't accept that. If you have 1 molecule of water below 0 degrees Celsius, you have a solid. It doesn't matter if there are other molecules of water. It's a solid.
Okay, can we put it like this? You know, for example, a steel can have different states, right? So we have different
course.
phases. Like, yeah, you can have, for example, austenitic steel, martensitic steel, and so on. And what kind of phase or state you have in the steel depends on how the different atoms arrange themselves with respect to each other.
Nope, not
Yes.
true. No. You're talking about how we determine what state there is.
Yeah, I think there are
Yes. So
kind of
how we
different
determine
meanings.
it?
I
No,
think
no.
it's
How we determine it is different to what it is.
How do you define, like, are states of matter emergent properties, or are states of matter consequential properties?
States of matter are consequential.
Are you sure?
It seems likely.
I
Some
think
states
that's
are
where I have
emergent.
to disagree.
Some states are emergent.
Yeah,
But
but you
like when
can't just say some states are emergent and then,
sure I
say
can.
it's consequential.
No, I said all states are consequential, but some states are emergent consequences.
Then how do you
But
distinguish between them?
I would still argue that
Because also,
I
for
would
instance, consciousness is an emergent property, but
Yeah.
consciousness is only a consequence of the physical laws and the chemical laws and the biological laws and the neurological laws. There's nothing about that that isn't consequential, but it is nonetheless emergent.
I would still argue that you can't have
But
you can't have
consciousness and the state of matter are different, right?
No, but we were arguing about whether or not you can have something that's both emergent and consequential, and I showed you that you can.
Yeah, because consciousness is one of the mysterious things, but the states of matter aren't that mysterious, right? Because we can empirically test.
No, but I think the point was that you made an argument that I couldn't have the thing I said I had, and I showed you another example of me having it.
Could you please describe what a solid is? What was the definition of a solid?
Yeah, could you describe its properties, like consequential properties?
Because this is key to our discussion, really.
Let me see. Structural rigidity and resistance to changes of shape or volume.
So all of those imply that there is an arrangement.
Oh, but
No,
what,
but I don't think you understand though.
what is a
That's
solid?
listen. When it says it's characterized by, you realize that that's a consequence. Like the characteristic is a consequence of some other property, right? So, for instance, temperature. If
Yeah.
the temperature is such that it is in a certain state, then even if you only have one atom of the fucking element, it is in the state that corresponds with the temperature.
So you're saying with one molecule of water,
Here's what I'm
if you
saying. Here's
get
what I'm saying is,
if you
with
get it to
one molecule
100
of water, yes, it becomes
Okay.
steam.
I
Exactly.
think we're missing the
No,
word state
Terence
can
just
have.
got it on point though, right? It's the idea is if you have one molecule of water and you get it to 100 degrees, it becomes a gas. It does. Like we can
But
prove that it does.
wouldn't it become a gas before 100 degrees because it's one
Oh, I don't
molecule
know.
of water?
Maybe. I don't know. That's not the point. The point is
That's
when
the
it.
whole point, dude.
No,
That's
no,
the
no.
whole
It's
point
not the whole
because
point. The whole point
because
Oh,
is
no.
you and Angifa were arguing that it doesn't become a gas unless there are multiple molecules. That's what you guys were saying. I'm saying obviously that isn't true because when we heat one molecule of water
yeah,
up, we can observe it become a gas, even if it isn't at 100
exactly.
degrees.
But
When the
but
temperature
but the
becomes
properties
sufficient for a gas.
but the consequential properties you assigned, like 100 degrees will turn it into a gas, right? It's not true for one molecule. It's true for the
Well, that's
arrangement of
irrelevant.
molecules.
No, stop.
Yeah.
It's
Yes.
irrelevant
It's
what
a
the
matter of
number is.
definitions. It's a
No,
matter of
no, no.
definition.
The
I think.
number is irrelevant. The point is, if changing the temperature upwards a sufficient amount changes the property of the molecule, then it has changed fate. It is
Okay.
changed state.
But
Like it
can
has
we put
become
it?
a gas.
Can we put it like this? Say I have 1,000,000 iron atoms just scattered around, and would you regard them as a solid at room temperature?
Oh yeah, probably yeah.
Okay, but a solid you have to the definition of a solid is that
Oh,
there
yeah,
are
you still
closely
didn't define a
packed
solid.
together. Yeah, they are. Then they are
I
closely
did define
packed
a
together.
solid. I said it's characterized by structural rigidity and resistance
No,
to change
not
shape or
characteristics,
volume.
but consequential
Yeah.
properties.
No,
Yeah.
dude. That's how it's defined. Okay, I'm
No,
saying
a
we
solid-
define it. Stop. I'm saying we define it based on how we determine it. All right. But the things that we're using to determine it are not the reason that it is that way. The
Then
reason it is
how do
that
you know
way.
what is the truth? Like what is like
Because
what
there's something in
Oh, okay.
common, which is temperature.
Okay, I think I know. I know where you're coming from now.
you're just pointing out the consequential properties of what
No,
it's
I'm saying there's a phenomenological commonality among the consequential properties, which is temperature.
Yes.
Yes, so the temperature change is what is actually linked to the phase change.
Yeah,
To
it's
the state
phase. Yeah,
change.
that is true.
Yeah.
That is true. But here, the most important part is the number of molecules and the arrangement.
No, but that's
Yeah.
what I'm saying. What I'm saying is that if the temperature of one molecule reaches a level that is sufficient to change it to a gas, it does change to a gas, even if there's only one of them.
It does change into a gas.
It does.
It doesn't change anything. It just
It
had more
does.
energy before.
No, but that's exactly what the change into gas means. When it has
Yes,
more
but-
energy.
but-
Stop.
that's like-
When it has more energy, it moves in a different way to when it was a liquid. Okay, it actually gains a property, which is that it moves freely. That's what a gas is.
In relation to the arrangement.
Yeah.
No, not in relation to the
yeah.
arrangement. By itself, it moves freely now.
Yes, but you're defining the whole phase change and the states of matter due to the in relation to the
No, I'm
arrangement
not.
itself.
No, I am not. I'm saying if on a fucking petri dish in a vacuum, I have one molecule of H2O, alright, and then I raise the temperature of that vacuum, alright, such that the molecule gains energy, and then the molecule starts moving off the face of the petri dish and hitting the containers of like the sides of the container of the vacuum, right? We can observe it has changed in properties. Even if there's only one molecule in a vacuum, it has
changed
changed.
properties, but can you say change the state of matter?
That's exactly what a change in state of matter is. It's different properties.
In relation.
No. It's not the.
It's a semantic error.
It's
not
not
a semantic
It's
error.
not how we define.
How we define it is
define
based
it.
on how we determine it.
Yeah.
I'm saying our determination is irrelevant, though.
Then how the fuck are you gonna define it?
Because I'm saying that there's a commonality among the thing that we're using to define it. Okay, we're using what we can use to determine that something has changed. I'm saying in all of the cases where we're determining something has changed, there is a common change, which is the temperature.
Yes. The common change for every molecule in the structure.
Yes, but irrelevant. The point is, if the temperature is the common element, then I can take one molecule away from the rest of them. That's what a vacuum means. And if one molecule in isolation exhibits a property change in relation to a temperature change, then what we have is a change in the properties that we call a state change.
No, we don't call that a state change.
I don't agree with you. If one molecule on the surface of a petri dish gains energy from a temperature change and starts moving freely around the container, it has changed to a gas. It has changed to a gas.
Yeah, but the whole solid liquid gas.
No, it's a vacuum. It's a vacuum. There's no structure around it, Terence.
Then you have.
Okay, but you're defining that phenomena as a phase change.
Yes, I am, but that's the word that we always use.
Okay,
of course, but that is the word that we use. It is when we have temperature-linked property changes. Those are called phase changes in chemistry.
Yeah,
they
but
are.
phases are mostly related to the arrangement of the
it doesn't
Mostly,
change. It doesn't
mostly
have
they are. That's irrelevant.
I don't think it has such a state. It's just then it is thermally agitated. That's the difference.
What?
Yeah, if you induce
Thermally
heat,
agitated.
yeah, if you induce
Thermally
heat,
agitated is the technical name for a phase change to a gas. Like all gases are just thermally agitated molecules.
but we don't. We define what a gas, liquid, and solid is.
No, we define gases by how we determine that they are thermally agitated clouds of molecules. But the point is, the property that we're defining when we make the determination is that they are thermally agitated, yes or no?
Yes, but
No,
your
no, no,
Yes,
no.
so
presupposing.
stop. You just said it, yes. So
No.
Terrence said
I
yes. What's your
said yes.
objection? What's your objection, dude?
Oh, I still have the objection that it is the words we use, solid, for example. We define it as how a lot of particles are closely packed together, and they are stuck together by, for example.
You're talking about how we determine it.
Yeah.
Yes, but that's not how we define it. That's that's not how we define it. That's how we determine it. No, it's not. Listen, the definition.
Okay, wait. I think in sync is right because the definition of a state of matter is one of the distinct forms in which matter can exist.
Mm-hmm.
Not in an arrangement, but in 4 states. Matter are
Correct.
observed in every.
What states? Okay, can you please link that so I can read?
Oh, just Google states of matter.
Okay. Okay.
Like, yeah, it absolutely has to do with properties of the matter. And like, it's really important that we remember that there's a difference between how we determine that something is true and what makes it true.
So there's a difference between how we determine the existence of an electron and what an electron is.
Yes, correct.
But then, okay, so matter is anything that has mass and takes up space, right?
Mm-hmm.
And energy is the capacity to cause change.
Takes up space-time.
Energy is not the capacity to cause change, but I'm willing to accept that.
Okay. Okay, and then we have 5 different which matter can arrange itself in.
I believe there's more than that, but yeah. I'm pretty sure there are 7.
And the main difference between those structures is that it says here the main difference in the structures of each state is in the densities of the particles.
Mm-hmm. And density is a property, right?
Yes.
Yes, so it's in the properties of the particles.
Of the material, yeah.
Yeah, that's what I said.
But density has to do with how closely packed.
No, but density is a property of an individual particle. It's how closely it will pack when put into an arrangement.
Yeah. But then what about if we take 2 or 3 different atoms and put them together?
Oh, yeah.
I think density is a property of the system, not of the individual.
No, because then the density of the collection would be the aggregate of the densities, right? Like you'd be saying, like, how dense can this collection of things be, considering that A is this dense, B is this dense, and C is this dense? Like individual molecules have a density, man.
Yeah, they have.
Yes, so it is the collection of the molecules that generate your measurement of density, but the density exists as a property of the particle. Like, this is what I'm saying. There's a difference between how you measure the density and what the density actually is.
Yeah, okay, you're right about that.
This is heresy, dude.
Oh, this is some deep shit, man.
It's a good question. You know,
So-
like I said, I don't know what the answer is.
What's the answer? Like one molecule of water on ice.
I don't know, man. I actually just don't know. I'm not sure. You know, I feel like the answer is that if wetness is a property that emerges from the aggregation of water molecules, then 3 water molecules mean that at least one of the water molecules is wet. I don't see how you can get around that.
Because wetness depends on water plus something else.
I don't
and
actually
here
accept
it's
that. I
water
don't
plus
accept
water.
that. Yeah, I
But
don't
it's
accept
here
that.
it's
I'm
water
saying,
plus water.
Why don't we
here's what I'm
just
saying.
search for the definition in be easier?
I'm saying, like, wetness is to do with the aggregation of the water molecules. It doesn't have anything to do.
I don't accept that. It has to do with the aggregation of water molecules plus something
Okay,
else.
but which one of those is more important? Is it the plus something else, or is
Plus
it the
something else is
aggregation?
important.
But no, but which is more important?
There is no more important. It's
There
one
is.
thing.
There
It
is.
has to
It's easy.
exist.
Let's examine it. We examined it before, right? If we have one water molecule plus the something else, then we have one of 2 conditions, all right? If we have one...
Yes, but when we
Well,
say
no,
something
so
else, it's not water.
no, but the point is that if, like I said, if we say B is book, I have 1 molecule of book and 1 molecule of water, the book is not wet. We agreed on that. So wetness cannot be just the fact that there is something else, all right? And I'm saying if 2 molecules of water on the book make the book wet, I don't see why 2 molecules of water on another molecule of water wouldn't make the water wet.
Because
Why is
water
that?
and water are the same thing.
Yes, so?
That's the whole point. The premise is there has to be water plus something else. If there's
No,
water
that's
plus water,
your
that's just a
premise.
liquid.
I'm saying that premise does not hold up. It cannot just be there has to be water plus something else. You're saying there has to be at least 2 molecules of water plus something else, and I'm saying, well, it looks to me like the fact that there are 2 molecules necessarily is more important than the something else.
I would argue
No,
that
but
if you
it's
have
like
2
the
water
molecules of
molecules,
water would react differently with different substances
but
rather than
if you have 2 water molecules, they would probably bind, right?
Yes.
Yeah.
So
And
then
so that's why I would say that if you have 3, then the first
The
water
tree would
molecule.
bind too.
that
I
they will
agree
bind
with you.
too.
I
yeah.
agree they would bind, but the point is that when we say we have one book, so let's say for instance we have salt, okay, because salt actually binds with water as well. If we have 1 piece of salt and 2 molecules of water, is the salt wet?
Yes.
Because your answer is actually no.
Then the sea is
right?
wet.
Yeah, your answer is no, Terence, because when the water touches the salt, it actually encompasses the salt and it becomes salt water, right? So if it becomes salt water, the salt cannot be wet. It's not there anymore.
Yes, I agree.
Okay, but I think most people would agree that salt does get wet when you put water on it.
But it gets dissolved. It's semantics.
Correct, but it's wet first.
It's wet first. Yes, I would agree to that.
Okay, so then the wetness is what? It's the collection of the
property.
aggregation of the water on something else. That's what you're saying?
Yes.
Okay. That would make sense. Let me think.
But if you have an aggregation of water
Wait, you
on
little
water,
motherfucker. Wait, you little motherfucker. I'm thinking. We agreed that you said that if it's not, the salt's not wet if it's not there. That's probably true. They're ions. Okay. So you're saying, but the water is there. The other molecule of water isn't dissolved. It just binds to it. That's not quite the same. Okay, so is the Na wet? Yeah. Is the sodium ion, is that wet? I would say yes.
Sodium ions aren't.
Why? If it's salt water, then the sodium ion.
Transition from They transition from wetness to being dissolved.
No, I don't accept that. The sodium ion does not transition from wetness to being dissolved. It transitions from chemical bond
Oh, wait.
to.
The sodium ion emerges after.
Yes, correct. But
after
the question I'm
yes,
asking
it's not
is
wet.
but since it's something else, sodium ion is something that isn't water, but it is surrounded by water molecules. So is the
Oh my
sodium ion
God.
wet?
Mm,
It would have to be.
yeah, by definition.
Okay, so the sodium ion, yeah, then the water has to be wet, in my opinion.
Water can't
I
be
don't.
wet.
No. I think that is
No.
a supposition. You're saying water is the only thing that can't be wet, and I don't
No.
actually take
If
that
you
to
have
be
the
a.
same liquid,
No,
if you
I
have the
understand.
same
I understand, but I don't think that's true.
Why?
I think because I think when you have an inkwell, the ink in and of itself is wet. It's not that the ink is wet on the page; it's wet in the well.
No, it's wet in regards to how you would
No,
test it.
no.
It's not wet.
I'm saying the water being a collection of the molecules is wet in and of itself, and that seems to be true.
So the ocean is wet.
Yeah, of course it is.
Wow. Doesn't that seem weird
No,
to you?
no, that's soaking, man. But
So
Instinct, I think I agree with you on everything regarding solids and liquids and so on, except that
yeah, water on
that
water is not.
we don't define solids and liquids and so on. We don't define a single molecule as
yeah, I know we
solid
don't
or
tend to
liquid.
define it. I know we don't tend to do that, but that's not what I was getting at.
Yeah, but I agree that it all has to do with
The phase change happens with one
temperature
molecule,
and
yes.
Like we don't tend to make that kind of determination because it's not useful. But ultimately, it seems like the determination we're making collapses to that.
yeah, sure. So, and then again, single
The ocean is not wet.
single
The
molecule
ocean is wet, dude.
It is the solvent. Sorry, it is the
Or-
solution itself.
Dude, I don't actually think it's reasonable to say that it needs to be something else for it to be wet. Okay,
Why?
because first of all, other substances are wet. So if I put oil in water, then the water
No,
is
no,
wet
not
because
this
of the
physics.
oil, and the oil is wet because of the water, right?
Yes.
Yeah, so no, that just seems like such an arbitrary distinction at that stage. If you're saying that the water can be wet because of oil, but not wet because of water, I say, what? Like, what?
But there are different densities of liquid.
Yes, of
Liquid
course,
on
but I don't
liquid is
think.
different.
No, I
Liquid on
understand.
liquid is different than wet.
I'm saying, I don't think the wetness comes from the difference in the chemical. I don't think that's where it comes from.
Then where like what is the
I think
property?
it comes from the aggregation of the molecules. If you have two or more of the molecule that is a liquid, then it's wet.
But that's just half of it.
No, but that's your opinion. I haven't seen any evidence that that's half of it.
I think we have to regard this definition on the macro scale.
You're saying two or more. That's an arrangement on itself.
Of course.
Yeah, but it
I'm
can't
saying,
be in vacuum space, and you
no,
can't
but
say
I'm saying, the thing that you're saying about the other liquid, I don't see why that's true. It seems just as valid to me to say that the water is wet before you put oil in it as after. Both of those seem wet.
how can it be wet in and on itself?
Because
It's a liquid.
this.
Oh yeah, you
Because-
have a wet paint, right?
Yeah, you do.
Wet
Yeah.
paint is on something. That's why
No,
it's wet.
dude, it's wet in the can. It's not just insofar as the paint is
That's
touching
a
the can that it's
hydrophobic.
wet. No, the point is that when the liquid is collected such that it's touching itself a lot, it's wet.
Okay, wait. Do you agree that wetness is a property of hydration?
No, wetness is a property of the aggregation of the molecules.
Okay. No. No.
Well, I mean, like, that seems to fit more with the intuitive use of wetness. When you have a bucket full of water, the surface of the water is wet.
Yeah, but hydration goes into chemical properties as
No,
well. So, like,
hydration has to do with water specifically. Wetness isn't just, like, it's not just based on water.
so a
Hydro.
lava on a boulder is like lava on a boulder.
That's not
Is the
hydration.
boulder wet or the lava wet?
What? So you're asking, okay.
Lava
No,
on a
that's a
boulder.
good question. That's a good question. Let me think. Well, the boulder would be wet. But
Why? Why
surely,
isn't the lava
surely
wet?
the lava, both. Yeah, the lava's wet as well.
How can
Does it if it
so
has
is
to
the
do with
whole system
hydration?
wet?
No, but it doesn't have to do with hydration.
Oh no, okay. Yeah,
So
then
is the
it's
whole planet wet?
No.
Yeah.
Why would you think that?
Because the aggregation of water molecules, like the oceans,
Yeah,
right?
but where the aggregation of water molecules isn't touching the earth, it's not wet. So like in my apartment, I'm like sitting here, and
Oh,
there is
it's
no
wet.
aggregation of water molecules here.
Yeah. There's plenty of water in the air.
No, of course. I'm just saying, like, there's no particular aggregation of water molecules on the
But
surface
is
that
the
I'm looking at.
atmosphere wet? Is the atmosphere wet?
No, I think that when we're saying wet, we mean the aggregation of water molecules that are in the liquid state.
Oh, now you're
Yeah, you're right. I had to change my definition slightly. That was a good question, you know what I mean? But ultimately, it does seem to be to do with aggregation.
But you're saying the aggregation of water molecules in a liquid state.
No,
What
the
are the
aggregation
conditions?
of any particular molecule in the liquid state.
Oh yeah. Basically, when we're saying water, we mean a liquid. All right. Okay. So
I don't think the person who made up the word wet thought about this.
yeah. Dude,
Look, I don't know what the answer is, but it seems like the answer is that if
but your opinion is really counterintuitive, and you don't have proper evidence to back it up.
I mean, I don't know if that's true. I've been trying to give you the evidence that I have for like at
Evidence
least half an hour.
that's explaining it, right? But
Yeah, that's
not
called rational evidence.
But
Yeah,
rationalism,
I see where
rationality
you're
is another
coming
school
from.
of thought.
But I think we have to go by the definitions we have. For example,
course.
if we define in the dictionary that wet that has to do with liquid being on some surface, that's what it is.
But
Of
on the
course.
surface of another liquid,
And-
can it be on the surface of another liquid?
And for our utilitarian
No, but I think what I'm saying
uses
is like
we define a liquid as how atoms arrange themselves with respect to each other. So isn't that what really matters?
I mean, I'm not accepting
With
the
respect to
pragmatic theory
wetness?
of truth. I'm not accepting the pragmatic theory of truth. So we're dealing with a word that's defined as covered or saturated with water or another liquid. And I'm saying one molecule of water can be saturated with other molecules of water. It absolutely can be. It can be covered with other molecules of water. That's the case. When you have a bucket full of water, one of the water molecules in the middle of the bucket is completely surrounded by the other molecules of water. How is it not wet? Like the idea.
It would depend a lot on of your perception. For example, if you're looking at inside an electron microscope, maybe like an STM or something, where you can see the atoms, then you might see it as wet. But with our own eyes on the macro scale, we won't notice.
It looks wet to me, and I think like what I'm saying is, for instance, if I can put my hand in the bucket and then my hand becomes wet, then the water must have been wet to begin with.
Yeah, but
Because the wetness doesn't emerge from my hand.
Say if you have a bucket with one water molecule and you put your hand in it, and then you get the water molecule on your hand, but you will never notice this.
Then it wouldn't be wet though, because it would just be one.
Oh yeah, say if there were
There's
3
two.
or
There's
5
3.
or
Okay.
something.
Yeah, let's say there's 3.
Or 100. It doesn't matter.
Let's
So,
just use 3.
Yeah, 3. So and you put your hand in it.
Yep.
And so you won't notice.
That's true. But you would still be wet though, right?
Yeah, it depends on. Are you really wet?
Yes.
Does it really happen
if
you
you
don't
can't
notice?
tell? Yes, I'm firmly of the position that things are real independently of whether or not you know about them.
Okay, so you're not a fan of Schrödinger then?
No, I think Schrödinger was showing us something, but what he was showing us was something about perception, not something about reality.
Yeah.
Well, yeah, kinda, but like he devised the thought experiment with
Yeah, I know, dude.
yeah, subatomic interaction with a macro scale.
Yeah, I understand what it's about, man.
So like, yo, what's the most wise thing you can say about the nature of reality?
About the nature of reality.
Yeah.
Oh, let me think for a second.
Hey, Terrence.
Okay, how about this?
Wait, yeah.
Sorry, go, Vinny.
I was just gonna. I don't want to tear. If you're wrapped up in a debate, then I'll wait until after. But
No, that's
I had
cool.
He's dropping some wisdom on the nature of reality.
Yeah.
Oh, okay. Okay, cool. I just wanted to drop a book idea off with you before, after this argument. So you can go ahead.
Not an argument. He's dropping knowledge.
Oh, okay. Hey, chill. Chill. It's okay.
Okay, so how about this? All things which are logically possible eternally exist because the opposite of eternal existence is not possible.
But
all energy goes somewhere.
Are you saying logical possibility has an absolute nature to it?
I'm saying that there is an absolute basis that logically entails possibility. Yes.
Wait a second. I just stumbled upon something and kind of what you were saying. I think I did. I'm not sure. So all things that are illogical are objective, or I'm sorry, logical and illogical concepts are objective. They can't be subjective. Is that true?
Nope.
That has to do with
if we were going to say galactically, I'm just saying it's
not articulated properly. That's the problem.
Oh, okay.
So I think what they're trying to say is that whether a statement is logical or illogical is not a matter of subjective opinion. I think that's what they were aiming for.
Gotcha. All right.
Yeah, but how could you claim that? How could you claim the logical objectivity of something?
No, you couldn't. I think what they were trying to say, though, is that whether or not something actually is logical or illogical isn't based on your opinion of it. It's based on the rules.
Based on what? Like
the rules.
Rules of what?
The rules of thought, for instance.
The rules of the laws of nature?
Yeah, the laws of nature, which we approximate with the laws of thought.
Right.
So, for instance,
it depends on the rules of language too.
Terrence, for instance, right? Let's say you make a self-contradictory proposition, but you think that you're making sense. Whether or not you're making sense isn't a matter of opinion. It's a matter of fact.
Yeah, it can't really be.
Yes and no.
Oh, go ahead.
It's not a matter of opinion. Based on the fact that he contradicted himself, he isn't making sense. The law of non-contradiction deterministically concludes he didn't make sense.
What if by judging my position, you are coming up with the contradictions?
I'm not.
Yeah, but hypothetically. Does it still...
No.
If we were to enter...
that I'm wrong?
No, it doesn't. If I contradict myself, then anything I have to say about your position is inherently nonsense.
Yeah,
Like
if there,
like between two people, like who would judge that? Who would validate the
That's why you
objective
have.
nature?
That's why you have more than two people, dude.
well, so if you're going to say that if you're going to say that mankind isn't a good enough, I think are you trying to arrive at that conclusion that mankind's
So
not
are
a good
you
enough
saying
one to
for
judge the laws
having
of nature or what's objective and subjective? Is that what you're trying to arrive at, Terrence?
not quite. I'm asking if like so if there are three people you can have objective truths. And if there are two
No,
people you can't
that's
have
not what I
objective.
said.
If
That's
you
not what I
have
said.
2 million people, can you have an objective truth?
No, I said that the more people
boy.
you have, the more likely you are that your opinion on truth is going to be accurate.
Yeah, it kind of builds like a percentage, right? It's not that you're
Yeah,
it's
it's
not that you're dead
probabilistic.
on, but yeah, okay, probabilistic. I like that.
Okay, but what about this? Say if you're going to steer a ship, and you have one captain who's really good at steering that ship, and then you have 5,000 other people on who knows nothing about the sea whatsoever. But they argue for one thing. Let's say we should go this direction, and the captain says, no, we have to go this direction. Are they right based solely on
No,
their
of course
superior
not.
numbers?
Ridiculous.
Oh,
But here's
Yeah,
what is
that's a good
true. Here's what is
I agree
true.
with that.
Is that if 5,000 people say one thing and one person says another thing, that one person should try really hard to understand why 5,000 people agree on something else.
Yeah, but
What
they
if
can
the
still be
reason is
wrong,
they're
right?
stupid?
No. But here's the thing: is what if the captain can't see an iceberg that everybody else can see? He could be wrong, right?
Yeah, he could be wrong, but he could
Yeah, so
also be
he
right.
needs no. But the point is that 5,000 people all agreeing on something shows
So
you that
you're saying
you really need to be careful about claiming that you're right.
Oh
you're
yeah,
saying
that's
the
true.
majority should always be given the benefit of the doubt.
Yes. Yeah, absolutely.
Okay.
Yeah, you should definitely hear a majority out always.
Yeah, that's true, but it doesn't necessarily mean they're
but
No,
that
they're
but
right.
doesn't.
I'm not saying
Majority is
that
absolute.
it means it's true. I never said that. I said even if you have a billion people, even if you have 100 billion people, the fact that everybody agrees doesn't make it true. But 100 billion people agreeing is more likely to indicate a correct conclusion than 100 people agreeing.
Yeah, in some sense.
It is more likely, like
Is this a
probabilistically.
is this a
Yeah,
utilitarian concept?
If you have a complete random sample of people.
Oh yeah, of
Well,
course. But
if you have 100 experts and you have 10,000 ignorant people.
Of course. But random is implied, don't you think?
Yeah. Okay.
Thank you for listening. Like, share, subscribe, and join us in the Nameless Debates Discord. We hope to see you there.